In this topic, we'll look at how to pass command line arguments to a C program, and along the way we'll deal with arrays of pointers. When you run a compiled C program from the command line, you may include command line arguments, additional strings after the program name to indicate options, file names, etc. Now, so far none of our C programs have used such arguments, but most of the Unix commands that you run are actually compiled C programs. And they take various command line arguments, like ls-l or vi filename.c. There are various ways to attach these additional strings of information to a command, depending on the context and the operating system. If you're using a command line interface, a Unix one, it's just a matter of typing the additional arguments. But even if you're using an IDE for C development, Visual Studio, you find that it offers some way of setting command line arguments to be provided to your program when you run it. Even in a modern GUI interface, programs use command line arguments behind the scenes to get options and additional information that's needed as the program starts up. So GUIs generally provide a way to attach command line arguments to the program that is run even when you just click an icon. In our example, we'll just use Unix command line execution and add arguments directly to the command line. For instance, as the sample run here shows, assuming our executable is named prog, we can pass the command line arguments -ab and cd to our program by the command shown here. Now, any command line arguments passed to a C program show up as parameters to main. Thus far, we've written main as though it had no parameters, parameterless function. And in fact, a C program may ignore any command line parameters by simply omitting the declaration of the parameters in main. But whether we declare them or ignore them, main is always passed two parameters that have to do with command line arguments, and which are by tradition named argc and argv, as you can see on line 19 here. That, by the way, is just tradition, not required by the language. Now, the argc parameter is fairly simple. It's an int indicating how many command line arguments there are. Now, it's mostly simple. The only complexity is that the name of the program executable itself, prog in our example, counts as the first command line argument. So you always get at least one command line argument for free, and argc is never less than 1. In the sample run on line 32 there are thus 3 command line arguments, and argc would then be 3. The argv parameter, a double pointer, is rather more complex, and it leads to all of the command line arguments in the form of a block of character pointers, each, the first element of which is pointed to by argv. Now, this is the first example we've had of an array or memory block of pointers. C allows arrays or memory blocks of almost any type, including pointer types. Every element in this block here pointed to by argv, is a character pointer pointing to some string. The vertical orientation, by the way, is just for clarity. We could have drawn it horizontally, too. Each command line argument appears as a null-terminated string pointed to by one of the elements of the block. As we said, argv points to the first element of the block. Just as a pointer to the first element of an array of ints has to be a pointer to an int, so a pointer to the first element of an array of char pointers must be a pointer to a char pointer, a double pointer like argv. Now, we can index into the block using argv, just as we did with simpler blocks in the earlier lectures on pointers, arrays, and dynamic block allocation. Indexing argv results in offsetting from argv and doing a single dereference, thus arriving at one of the character pointers in the block. Argv bracket 1, for instance, is a char pointer, the second one in the block highlighted here. It's neither a double pointer, since we did one dereference by virtue of bracketing, nor is it a char, since we did only one dereference, not two. As you work with double and higher order pointers, it's important to keep careful track of what level of pointer you're at as you dereference or index, and we'll do that in this discussion. Now, a couple of other details about that block of pointers. First, it's not dynamically allocated on the runtime heap. It's instead created automatically in another area of memory as part of the program's startup. So you don't need to free it, and in fact doing so would be a serious error. And second, as you can see in our diagram, it includes one extra null element, the fourth element in our example. This is sometimes convenient as an end marker when you iterate through the block. With all this, you can then see that the printf on lines 22, and 23 here prints the three command line arguments, with the first one being the command name itself, as we earlier promised. The %s format specifiers are correct because we're passing character pointers to printf. And per usual, printf doesn't care where we get our pointers as long as they point to null-terminated character sequences. The output down here, of course, shows the result. Now, the print_args function also prints all the command line arguments, but more flexibly, without assuming that there are just 3 of them. And it will use pure pointer notation rather than indexing. So, going to that code, it starts by printing the argument count and the first command line argument. Be sure you see why *argv is the first argument. It's a synonym for argv bracket 0, of course. And since it has only one asterisk, it's a character pointer, not a character, and of course not a double pointer. By the way, for complete clarity, we should show that argv is duplicated up here, right? Passed it as a parameter. It's not the one in the main, although it points to the same place. The loop on lines 5 through 6 here then iterates argc times, printing the rest of the arguments. And in question 1, no, actually it doesn't do that. What's incorrect about me saying that this loop will iterate argc number of times? Coming back from a pause, a lot of this exercise is going to deal with post and pre-increments, and we want you to be thinking carefully about it. It iterates argc minus 1 times. If argc is 3, it'll go 2 times. And that's a pre-decrement argument there. So it'll reduce argc to 2, and then to 1, and the last time to 0, and it won't run the while loop. So 2 times only, not 3. Now, line 6 advances argv down the array of pointers, incrementing it to point to each element in turn on each loop iteration, and dereferencing it once to arrive at the character pointer. So let's see here. Since it uses a pre-increment, the printf prints the second, third arguments, skipping the first. Let's try it out here. On the first time through, it'll advance argv to point 1 forward, and that's the result of the ++, and then it will star that to get the actual pointer there, and that is what we pass to printf. And then on the second time through, again, pre-increment advances argv to point here, we dereference it, and pass that to printf, and we get the third command line argument, or argv bracket 2. Now, returning down to the main, look at the second printargs call on line 25, where we pass the array of pointer. And that array is declared and initialized up on line 20 here. This is an array of char pointers to show how you might declare such an array directly instead of indirectly via getting argv. Note the *array name bracket dim syntax here. It suggests, I guess, that we would index the array and then dereference the result of the index, which is exactly what we would do for an array of pointers. And that's the pattern you use in a declaration for an array of pointers. So question 2, just a quick reality check. How do I get away with using quoted strings to initialize array of pointer? Wouldn't I have to have addresses or something to initialize its elements? Or will the elements of array of pointer point if I initialize it this way? Returning from a pause there. Yeah, you can do this. You need char addresses or character pointers to initialize the array, and that is exactly what string constants are, remember. So using quoted strings to initialize array of pointer is fine, and all its elements will point into the string table. Question 3, another quick reality check. What type is r of pointer by itself, as used here, for instance, in line 25, without any index? coming back from a pause, it's a double pointer to a char, or to be very exact, the address of a character pointer, the first character pointer in the array. And that's a double pointer, constant. It's usable as the value to pass to a double pointer, as we do for printargs. And thus, printargs works, as you can see from the output here on line 35, on our array just as well.